part 8, it is the regression. Okay, so let's see what's what's the regression. Okay. So I'm gonna start with explaining the regression part now. So when I talk about regression, regression is a statistical method used in finance, in investing, in finance and investing, and in other disciplines. It attempts, why do I need to know about regression? Why? Because it attempts to determine the strength and the character of the relationship between one dependent variable and the other variable. It might be between one dependent variable and other series of variables. So basically, I need to know what is the regression. So again, it determines the strength and the character of the relationship between my variables. So let's start with doing the regression. Here we have the linear regression. When I talk about linear, I mean it is the linearity means the straight line. So linear regression is to find the slope and the y-intercept of the best fit line. We're gonna reach a linear regression equation at the end. We're gonna describe it when we come to the end of this part. Okay. So we have to follow the below steps. Let's go for a regression analysis. Again, I'm determining the strength and the character of the relationship between my variables. So we have to click on analyze, regression and linear. So analyze, regression and linear. Can you see the linear here? We have also other types of regression. You might go for the nonlinear here. You might go for a curve estimation, partial least squares, but the others will be more advanced level of researchers. So I'm trying to make the general rules and the general guidelines so that each and every one of you will be able to implement these steps on SPSS. So let's go for the linear. I'm gonna click on linear. And again, we have this window. We have to insert the dependent variable and the independent variable. Okay, so we have to again insert these variables. Let's move forward with the steps. So regression and linear. So again, the dependent variables are the GDP and unemployment is the independent, as we previously did. So I have to put here the GDP and here the independent variable as unemployment. And then press OK. You can see after each window I've written here that you can copy paste it to the same Word document. So each and every action, each and every output you will have, you can take it and copy paste it into your Word document. So output is always can always be copy pasted. So let's go here and insert as we have already mentioned, GDP growth is dependent and unemployment is independent, and press OK. Okay. Okay, so here we have the model summary, the ANOVA, and again the same table. Okay, see. So first of all, let's analyze here. So we have the R squared, the adjusted R squared, the standard estimate of error. These are somehow advanced values we can get for the regression analysis. And here we can see the variables entered. I have entered here the unemployment with secondary. Okay, and as one variable, and the dependent variable is GDP growth. I didn't remove variables, by the way, and the method is I've entered variable. See? So the regression shows me the variables entered and the variables removed. So far, I didn't remove any variable. Here, the model summary for a little bit advanced values of regression analysis. And here is the ANOVA table. Basically, I'm not sure if most of you know what is the ANOVA table, but I'm going to explain it. ANOVA table is the analysis of variance. ANOVA, analysis of variance. It is an analysis tool used in statistics that splits an observed aggregate variability found inside a data set into two parts: systematic factors and random variables. or factors, systematic factors or random factors. The systematic factors have a statistical influence on the given data set. However, the random factors do not. So you basically need to know more about the ANOVA table. Maybe it might be on a later stages, but you need to know ANOVA table because it is a type of statistical test that determines if there is a statistically significant difference between two or more groups by testing. So you can name it. You can name it instead of ANOVA as analysis of variance, and it measures the variation of means and it draws inferences after careful analysis. So it's important to represent in your data the ANOVA table. So you can see here in the ANOVA, you can see the sum of squares, the degree of freedom, the mean square, the F value, and the significant value. I'm trying not to dig much into details because this is not a statistical course. I'm trying to make it an SPSS course, but you need to know the importance of these values. And here are the coefficients as well. With the you can see that each after or under each table, the dependent variable is stated because whenever you change the dependent variable, the values are changed otherwise. So this is the regression analysis you can reach while moving into the SPSS. You can see here the same values and the same results according to your okay. So let me explain more about the coefficient, this one. So the coefficient part of the output give us the value that we need to be able to write the regression equation. What do I mean by regression equation? The regression equation is the output, the ultimate output I need from doing all of this process. It is made up of the y-intercept. You know, when you draw a graph, the part in the let me check for you, the y-intercept. Okay, it's the part when the y, you can see here, it's the part while the graph, okay, look, this is a y-intercept. If you can see, it's the part, you can see it here, it's the part when the y curve intersects the line. So here we have two y-intercepts in this graph. See, it's 0, 3.5, and 7, 0. So this is a y-intercept, and this is an x-intercept. It intersects the x-axis. So we have two values here, one y-intercept and y-x-intercept. Okay, just to make it sure if you understand the y-intercept, because we need it here. Again, so to create the regression analysis, we need the intercept, or the so-called the y-intercept, and we need the slope. You're probably familiar with the slope. So let me show you the slope. It's basically a slope of a curve. This is how we calculate it. It's very easy. Most of you know. It's the change in y-axis, which is the delta y, minus the change of on the x-axis. So delta y, which is y2 minus y1, over delta x, which is x2 minus x1. This is the slope of the line. Okay, the slope, by the way, has 4 cases. It might be a zero slope. It might be positively sloped. It might be negatively sloped. It might be infinity slope. So there are 4 cases: 0, positive, negative, and infinity slope. So why I'm explaining this? Because you need to use this table, this SPSS result, to create the regression analysis needed for your research. That's why you're using SPSS, you know? So the coefficient part of the output gives us the values that we need to have to write our regression equation. So our regression equation is made up of the intercept plus the slope times the independent variable. By the way, it's the same as the y equal x plus b, the same form of y equal x plus b, the equation of straight line. So y equal ax plus b, the same as here. Dependent variable is equal to intercept plus slope times independent variable, y equal x plus b, not more, not less. So the slope is found at the intersection of the line labeled with the independent variable. So in this case, the slope is equal minus 0.549. See, minus 0.54. You can see it on the intersection of the line labeled, column labeled B. See here, see, this is the slope. So the SPSS will calculate the slope for you. No need to use the rule I've just mentioned, the delta y over delta x, the y2 minus y1 over x2 minus x1. That was the traditional rule, but I'm just repeating it because most of you know or took it in school, early stages of school, the rule of the slope. But no need to calculate it, no need to memorize it, because the SPSS will calculate the slope by its own. So here you can find the slope minus 0.549. Okay, in our result, by the way, it's here. See, here is our result, minus 0.549. And we also need to calculate the y-intercept. The y-intercept, it is minus 2.4, it's 24.892. Okay, so the y-intercept is the same as the intercept. And when I talk about y-intercept, it's the same as intercept. It is 24.892. Look, it's here. See, so the regression table calculated for us the variables or the numbers I need to write a regression equation. Well, that's awesome. No need to do it on your own, okay? So putting it all together, the regression equation is y hat. Okay, so here it's y hat, okay, equal to 24.892 minus 0.549x. It's in the form of y equal x plus b, but why here we have minus? Because the slope is negative. Okay, so minus 0.549. Whenever we have minus here, this means that the slope is negative. What does that mean? It means that there is a negative relation between variables, between y and x. Okay, or whatever variables we have chosen here. Here we have chosen the GDP and the unemployment. Okay. Okay, because as the unemployment increases, GDP decreases, etc., and this occurs with any other types of variables. So this is how we used the output results here, the output results, to be able to calculate our regression analysis table and equation. Okay, so we're basically done with this part. And I'm ready to either me or the Lloyd University to send this manual to your own emails. I might send it to Mr. Fahmina, and she will take your email addresses, and you can get this PDF file, because it's really easy to move forward with it. It has all the screenshots and all the steps. Let's move into another topic. I'm gonna minimize all of these topics, and let me move to the another topic, which is data manipulation. So what topics we covered so far? We covered topics about inserting data manually, extracting data, transforming data. We've reached also topics about here. You can see we've covered sorting the data, how to save it on SPSS, transforming it. We covered the huge topic about descriptive statistics. We described the case summaries. What does these summaries mean? We differentiated between measures of dispersion, measures of location. We explained each and every one of them. And what else did we do here? We differentiated between the correlation, the regression, and many other topics. We also showed some graphical representation, etc. So now we came into the data manipulation topic. Okay. Okay, so when I talk about data manipulation, well, this is a huge, interesting topic in SPSS. What do I mean by data manipulation? It means to organize or arrange the kind of structured data that is read by, or that's basically read by computer programs, so that it's easier to interpret. You know, our ultimate goal here is to make things easy to be interpreted by researchers. So SPSS basically is a tool that helps us to just facilitate things to be able to interpret our final results of our research. So the organizing or arranging the kind of structured data that's read by the computer programs is we're working on it with the data manipulation, and performing this process effectively can basically improve the quality of your data and analysis. That's why we need to see how does data manipulation goes with SPSS. So we have different forms of data manipulation. This demonstrates three types. We're going to talk about select cases here, split cases, and weight cases. So in data manipulation, we have three cases to talk about: select, split, and weight cases. So each and every one of these are going to be addressed by us here on SPSS. Okay, again, they are select cases, split cases, and weight cases. So let's start with select cases. So first of all, we need to select a part of the data set to do more and more analysis about it. See, let's say if I want to select a part of my analysis, if I'm talking basically about, let's say, GDP or unemployment, or any type of other data that I need to do more analysis about it. So I have to go and see how do I select these cases. And the important thing here is I'm excluding the remaining cases from this analysis. You know, so I'm doing I'm extracting the part I need to do further analysis about it, and then I will exclude the remaining cases from this analysis. How do I do this? Okay, so I've mentioned the screenshots again here for you. I will go to data, select cases, and then move forward. So data, see, select cases, it's here. It's at the end of the list, select cases. Okay, and here we have all cases, if condition is satisfied, random sample of cases based on a range or on a time or case range, or you might use filter variable. So let's move by these step by step. So first of all, we can select cases if, or we can take all cases. Okay, here we can take all cases, but our intention is to do what? Our intention is to take part of the data set. So let's start with setting a condition. So if condition is satisfied, okay, so first of all, we might go for all cases. See, data, select cases. We might go for all cases if you want. See here, all cases, it's the same as here. We might go for all cases, or if condition is satisfied, or random sample, etc. Let's start with the all cases. You can see it here. So SPSS basically allows us to select the part of the data in which we need. This will be by selecting select from the data menu and put select options within the dialog box that comes up, so we can tell or give order to SPSS which data to select and which to ignore or not. Okay, so here we came into the all cases. As you can see, all cases is this option that actually turns off any previous selection. So if you previously have done a selection, when you press all cases, it will make use all data in the file and delete all the previous selection. So we will click on this button and then click the OK button. So let's start with trying this all cases. I'm going to press all cases and press OK. So filter off, use all, execute. Okay, so this is how we are using the all cases. We are using the all cases option of our data, but we need to specify. We need to go into a specification and set a condition. So it's not of our interest. It's not a great importance for us. So I'm gonna go for data, select cases, and I'm go for if the condition is satisfied. If the condition is satisfied. So let me go for this option. See, so this option allows us to specify a rule based on values of variables. So all cases that meet the criteria are retained. See, so you're just giving an order to the SPSS. Please keep all cases that meet the criteria and take away all cases that does not meet the criteria. So after clicking this button, this option, you will click if option, and it will bring additional box, and we can define the rules for inclusion. Okay, so you can have this box and you will be able to define the rule of inclusion. Okay, so let's move forward with if. And here is let's say the GDP annual growth. Here we have the all variables. Here we have, let's say, all of these function groups. Let's keep it all general and press continue. And okay. So can you see here the order? The order is written. See, execute, it's the filter by not selected. So 0 is not selected and 1 is selected. So we're filtering according to GDP growth annual. See the condition? Let's go to our SPSS and see the data view. So you can see here the thing added here. You can see the filter. Okay, so 0 for not selected and 1 for selected, and any other type is for the selected. You can see the filter here. See, this is what we have done here. This column added is because we have commanded this filter. We filtered within the specific condition. Okay, so if you want to go for the other option, which is the select cases random sample. So here we can select a specified proportion of the use cases of a fixed number of cases at random. So you can click on the corresponding button and then click sample button. As you can see here, you will have this window. You can click approximately and list a percentage, and you can click exactly and list an exact case. Okay, let's go and do it. So random sample of cases, let's go and click random sample of cases. See this option, sample. Okay, you can have approximately a percentage of all cases, and you can determine exact cases. Okay, so what are we doing? We are selecting. Let's do approximately, let's, for instance, write 20% of all cases. Okay, and press continue. And okay, here the order is added. And let's go and see. So look at these dashed lines. You can see that 20% of the cases, and you can see that 0 and 1 apply or does not apply. So see 1, 1, 1, here, 1 and 1. And how many ones we have? 1, 2, 3, 4, 5, 6, 7. 7 ones. You can see according to the GDP annual growth. Okay, what if I increase this amount from 20 to 30, let's say? I'm gonna repeat the same procedure just to let you know what happens if I increase this amount from 20, let's say, to 50. Continue. Remember the values here? Let's put okay. So the ones, see, the dashed are decreased and the ones are increased. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cases that apply. See the difference when I increase the percentage. This is what I have mentioned here. This is what have been mentioned. So I filtered as 0 non-selected and 1 selected. So as much as I increase the percentage, more ones will be appearing here. Okay, this is if I'm talking about a percentage. I can talk about cases. Select cases, sample. You can see here, okay, it will be listed here approximately 50%. Let's go about a sample and press exactly. So let's say from case 1, 5, let's say. Continue. Let's see what happens on the SPSS. So you can see here, we have only one selected, one. You can see because I've determined the number of cases. I've determined the cases here, and all the others are filtered as 0. Okay, you can. I'm just putting examples on my own. You can just add own examples, etc. Okay, I'm just adding to my own numbers to make them clear for you. What's the difference between approximate sample size and exact sample size? If we want to go on a time or case range, let's come here. So these are the random sample. You can choose approximately or example. Here we came into a time or case range. This is to specify a range of cases based on the internal case number. A range of cases. So for instance, if you type here as per my example, if you type observation 4 till 8, this means that you are only selecting cases 4, 5, 6, 7, 8. So this is a range. See, this is a range included. By the way, it's inclusive. So 4 is included and 8 is included. It's not exclusive range. This range here is inclusive. So 4 is included and 8 is included. I mean, these two numbers you're mentioning, they are included also in the range. So let's go and do the same thing. For instance, if I go, okay, if I go here to my SPSS and press on the based on time or case range, and I need you to specify the range. Let's say from 4 till 8, for example, okay? This is just only to let you know. And the order is added here. See the list of orders. See the list of orders I'm doing. And let's go to the SPSS. Okay. See, I've included from 4 till 8. These are 4 till 8. Others are canceled. 1, 2, 3, 9, 10, 11, 12, etc. till 17 are canceled. Because I included only a range of cases. I only included a range of cases from 4 till 8. See? This is very interesting, by the way. This is very interesting. The very interesting aspect, the data modification on SPSS is a very interesting aspect you need to know. Okay. So everything is added to the output here. And let me move forward with the presentation. So here I included 4 and 8. You are working on these selected cases. You are working on 4 till 8 cases, and all of the other cases are neglected. Okay. Coming into splitting cases. Now that's an important thing to know. The split file option from the data menu, we're gonna go and implement it now on SPSS as well. It works similar to the select option, by the way, but there's a difference between select and split. So please do not mix select option and split option. They might be, you might think that they're the same. No, they're not the same. The difference is that we're going to be using the split function to repeat the same analysis separately or on multiple groups. Again, so the difference between split case and select option is that the split case, the split function will be used to repeat the same analysis separately on multiple groups, separate work. For instance, if we're gonna if you have the need to complete descriptive statistics, let's say here I give you an example of men and women. separately, we would like to split this the option from the data menu. See, we have to split because why? Because we are calculating the descriptive statistics separately. So we need to split. See, this is an important thing to point out. So again, we're gonna log into data, split, and let's go and implement it. So we have to press data, again, data, split file, and go to organize by groups. Okay, because we're just splitting the data and make them separate. Here we can specify the group. We can specify gender, for instance, and you can see that the split file on the lower hand corner of the SPSS window. So let's go and do it on the SPSS. See data, split file. Okay, we previously worked with select cases. Now we're working with split file. Okay, so let's choose this time Lin GDP, for instance. Okay, and organize output by groups. Okay, and let's put it here and press OK. The order is added on the output group, on the output page. And you can see here the Lin GDP. You can see here the Lin GDP added. And as you can see here, the column is added here as well. And you can see that we're basically working on splitting data. And we entered this variable, which is here in my case, it's the gender. Okay, and in the case I've implemented on the SPSS, it is the Lin. So what I've done is I've selected the gender here, for instance, or the Lin GDP to basically to split or repeat the same analysis but on a separate basis. Okay, so let's move into the other. So here we entered gender. We are doing any further analysis, and we were done separately for let's say for men and for women until we turn on the split file option. So we are always running now from now on separately for men and women for any types of variables we're analyzing until we turn off the split file option. So make sure you're turning it off. Whenever you turn it off, you have to mention analyze all cases, do not split groups. Analyze all cases, do not split groups. Here, look, because we need to deactivate function. Split file, so far it's activated. If I pressed on organize output by groups, so far it is activated. In order to deactivate this option, I need to press analyze all cases, do not create groups. This will be deactivating my split function. Okay, so this was by default, by the way. This was by default. I changed it into organize output by groups. So again, okay, I won't be, the order is mentioned, split file off. You can see split file off. Here now, sort cases, split, okay, split file by separate by Lin GDP previously, and now split file is off. So the split option on SPSS is deactivated now. You have to take care to deactivate it. See, analyze all cases, do not create groups. Okay, so we've mentioned that we have to sit, when I talk about data manipulation, I'm talking about three aspects. I'm talking about select cases, split cases, and now I came into the weight cases. What do I mean by weight cases? So sometimes there is a single variable in a data set that represents the number of occurrences of a behavior. When I talk about number of occurrences, I mean the frequency, the repetition. Okay, so the frequency, the repetition. So it's the amount of repetitive actions or repetitive occurrence or repetitive behavior. That's what we call frequency. So this case is used to represent a contingency table. Okay, so when I need to activate the weight cases, and the weight on message will appear on the SPSS. And when we select the weight cases, I'm going to implement it now. We have to weight cases by. See, let's go and implement it. Data. See, by the way, they're next to each other. Split file, select cases, and weight cases. They are all at the end of the list because they are all related to data manipulation. So weight cases. By default, ladies and gentlemen, by default, they are, it's mentioned do not weight cases. If you want to activate it, make sure to deactivate it again once we don't want to weight cases. So let's talk about the GDP growth, for instance, and make transform it into frequency table and press OK. Okay. So here is the output. The weight, it is the weight GDP growth annual. Okay, so you can see here the weight by the GDP growth annual. You can see here it is basically weighted by the GDP growth annual because we gave okay, so you can see here, by the way, it's still from 1 till 5, it's mentioned here. See, the sample is still mentioned. Okay, again, fine, it's okay. So basically it's from the...
Sorry to interrupt, Dr. Hala Faisal, but we can wind up in 10 minutes.
In 10 minutes, okay.
10 to 15 minutes, you can take 15 minutes, yes.
Okay, there is, I need to finalize these things. Okay, so let's move a little bit faster. So this is how we do the weight cases by and enter any variable you're looking for. And whenever you want to deactivate it, you press the do not weight cases. Let's move a little bit faster here where we're pressing do not weight cases. And here we came into the part of transforming and computing new variable. Well, this is also an important topic. The SPSS has powerful capabilities for creating new variables as a function of existing variable. You can use these functions to create averages of existing variables, to compute difference scores, to rescale existing variables, etc. So you can go to transform. You will be able here to go to transform. See? And press on compute variable. See? So here we are managing to create a new variable. So the new variable, it might be one you can choose. I've mentioned the steps here for you so that when you have the presentation, you will be able to do it by your own. So part A, B, C, D, F, and E. Okay, I've mentioned them. So target variable here, you will be able to insert the new variable that will be created. B, to add the numerical expression. C is C the numerical expression. B is to list the variables in your data set. And here is the function group. We did something similar to this. Okay, so let me go and implement it on the SPSS. So linen GDP is my target variable. It's already saved. Linen GDP annual growth, and let me press OK. Change existing variable. Okay, so the order here again is transforming a new variable. So this is how we do it. We created basically a new variable of from linen GDP to created the numerical expression of the variable. You can see here the target, any type of target variable, and the numerical expression of this variable. So moving forward, let me go and see these topics. 1 minute. So here we can include if. Okay, let me present it here. We can include all cases or include if the case satisfies condition. Again, the same thing, repeating the same procedure, but this time I'm including the if, I'm including condition. Moving forward, here we can compute variable let's say I'm talking about the target variable is minutes, its expression is study hours, for instance, you will see the minutes added to the, a new variable is added to your SPSS. You can see it here. See, when you add a new variable, compute variable, okay, when you do all of these, you can see that a new variable is added here. See, here, a new variable is added here. According to our presentation, it's a new variable is added here. It's the minutes, for instance. These are the old variables, and this is the new variable. Moving forward, this is how do we recode into different variables. Recoding can be done in two ways. You can recode into the same variable or recode into different variables. There are three main types of recoding: single, range of variables, or two categories. Let me directly show you how to do this recoding. Example, if we have recording single values, you press on, if we have batsman, let's say runs and number of runs by batsman, you can enter the data on SPSS, let's say enter the runs, click on transform, recode into different variables. It's here. Transform, recode into different variables, or recode into same variables. See? Okay. Let's move a little bit faster so we can do transform, recode. You can see these windows. You will enter the variables. In our example here, it's runs. In our example here, it's runs. Okay, and then you choose the name and the label, and you can see from runs till the labeled name. And this is how we include the value 120, the value 1, and we can just, what do I mean by recoding here? It's moving from old to new. So the things, when you enter here a number, it will be like this: 120 till 1, 86 till 2, 56 till 3, etc. So I'm recoding. I'm just doing the recoding example. If I'm willing to recode into different variables, the same procedure apply. Step 1, insert your variable. If it's not inserted, then recode different variables. Step 3 is enter the name and the label. The same thing applies. And here we have the list of old and the new variables. And here are the scores. You will be able to see this. Okay, so you will be able to see this on your SPSS function. More than that, recoding into categories, you can see all of these here. So here, recording into different, same variables, recording on different variables. You can see the recording into categories as well. So you have to enter and click into the, coming here. So if we have these scores, whenever you insert them, you put the ratings and then the name and the label, and then you come into this window. You just need to be to enter the value here, the ratings, and you will reach here to the old and then to the new. We're just recoding. So recording into the same variable, these are the steps, but you need to make sure that any changes made will permanently alter the original variable. So make sure that any changes you're doing will make it forever permanently changed. The original value will be replaced by the recorded values. And it is good to practice not to recode into the same variable because it overwrites the original variable. This is a very important thing to notice, okay? And here is a brief expression of univariate and bivariate statistics. I've already covered these two topics, but you need to basically revise them. I've already covered them in the descriptive analysis. This is how to do a bivariate and a univariate analysis. Last thing I need just to cover with you is this presentation. It will take only a few minutes. It's the presentation I prepared for you as a brief summary, because in SPSS there are lots and lots and lots of information you need to know. So I might also send you this presentation because it summarizes each and everything you need to know in SPSS. I hope that we can move forward with further sessions, but due to time considerations, we need to move forward. So We covered the data view and variable view, how to enter data, how to import external data, clean and edit, and to go to descriptive. This presentation shows examples and summaries of how to do modify data, clean data, case summaries. I've also excluded or included screenshots out of the results I've had. I've just did a repetitive summary just to make sure that things will be clear for you. This is a pie chart. By the way, we didn't include a pie chart, but you can also include it because some values need a good pie chart. And this is a histogram. I also mentioned the histogram. This is the box plot that we made, things like this. This is a histogram of age, box plot of age, and this is a histogram of duration of stay and box plot for the same. I hope these presentations, PDFs, and documents were very useful. Basically, it's too short to describe SPSS within this lecture. I hope we can meet further in the future. SPSS is a wonderful word, especially for those researchers that are looking for reliable software to move forward and rely on for their research methodology. This is only basic level ones. There are lots and lots of options in the SPSS you need to address. And that's it. Thank you, everyone. Thanks, Dr. Ruchi. Thanks, Dr. Fahmina. And that's it. Thank you so much. Thank you for your time.